When we did 3.1 and 3.2, 3.1 was factors, 3.2 was greatest common factors and lowest common multiples. I said that was going to lead up into fractions. Here we are, 3.3, representations of fractions. All right, fractions can have the same value, but they may look different. Okay, and this is about you taking control of the fractions, because if you don't take control of the fractions, just understand that they will take control of you. And yes, it's unfortunate, but over a lot of time, we found that fractions alone, not just including all of math, but they've been highly destructive to people and have destroyed many, many lives. And we hope that you'll be able to take control so that it will not destroy your life as well. All right? Now, another note about fractions, and I hope this isn't too late to be using food examples, but when we talk about fractions, I generally like to talk about food. Maybe that's a mischaracterization, because I do like to talk about food, generally speaking. But in any case, if we said, let's pretend, I'll try to make that better. Let's pretend like I just drew a nice sandwich right there, okay? And you can put some lettuce in there, and I would say, well, it'd be a big, long strip of bacon, I guess. And then what do you want there on tomatoes? BLT, there we go. Tomatoes are orange because I ran out of red for the bacon. So now let's say that we got this sandwich. I got this sandwich. We'll say it's my sandwich because I do like sandwiches and I do like BLTs. Well, this is a whole sandwich right here, and sandwiches are good. But let's say that I cut it in half, and let's pretend like that's directly in half. Don't worry about partial amounts here. But let's say that you get this half right here, okay? Now, mathematically speaking, as a fraction, we would say that you get one piece out of two pieces. And so we've seen this line before. It's just we weren't calling them necessarily fractions, just division right there, which is the same thing, by the way. You can get one piece out of two pieces of the sandwich, okay? But let's say that we went further, and I went and cut this sandwich into smaller pieces like this, okay? Well, now it's 4 pieces total, and how many pieces did you get? You got 2 pieces out of 4. So when we say that fractions have the same value but look different, just think about it like this. Would you rather have 1 piece out of 2, or would you rather have 2 pieces out of 4 pieces of this sandwich? And of course, if we look at just pure mathematics on this, it wouldn't matter if you wanted 1 piece out of 2 or 2 pieces out of 4. You'd get the same amount either way. So these two fractions have the same value, but they look different. And that's crucial to understand on this, because this is one of the things that destroys people with fractions is we can't distinguish between 2/4 and 1/2, like that there's a difference. Some people would say this is different than 1/2. It's not. In terms of its value, it does look different. And so there will be a need for you to take control of these, and at some point, you'll need to force fractions to have certain values in certain parts of the fractions. But this is about you taking control and not letting the numbers or the fractions specifically overwhelm you. And while that may sound weird because fractions are inanimate and have no real personality, although some people say that they're evil, yeah, it is possible that they can take control. And yeah, like I said before, they have destroyed many, many lives over many, many years. So, fractions are division, yep. So we've seen a fraction right like this one would be 12 divided by 2. Another way this is pronounced, if we look at this one specifically, this fraction, this would be said as a fraction 12 over 2. Okay, so that's another way that we look at fractions. We can say 12 over 2, like this one. This is another way to show a fraction, by the way, 12 over 2. 12/2 means 12 over 2. 12 divided by 2. So this also means that if you see a fraction, it is possible to write it as a full-blown division problem. In fact, if you wanted to, you could write it as long division as well, okay? But before, where we were using the vocabulary of dividend and divisor, which equals the quotient, now we're saying that the dividend, instead of saying dividend, well, okay, I apologize. Let me set this up first. The fraction indicates that the dividend is the top number, which we've seen, and the divisor is the bottom number, which we have also seen. It equals the quotient. The result is the quotient. But now we have new vocabulary for these fractions, and I hope that this is not the first time that you've heard this vocabulary, but if it is, that's okay. We're going to see that some examples not only in today's classwork, but in the homework as well. Just identifying the numerator and denominator. So the numerator now is the top number, but the numerator is the same as the dividend. And the denominator is also the divisor. It's the bottom number in the fraction. But again, the result is still the quotient. So keep in mind that fractions cannot have decimals in them. They should also not have fractions in them either. So if you see fractions with decimals or fractions within fractions, then we'll have to use whatever skills we can to eliminate fractions or decimals within fractions. Okay? And that gets a little complex in the future, and there's a little foreshadowing what I just said. But yeah, that gets a little complex in the future. But we are not going to be dealing with that today. Okay? So dividend, divisor. Now we're saying numerator and denominator. And yes, this terminology is so frequently used, not only in the rest of this class, but also in 950 and 980 and 1010, that you're going to want to, if you're not familiar with these, you're going to want to get those down as soon as possible, because this unit 3 or module 3 is almost completely about fractions. And so yes, we're going to see more factoring and finding multiples when we start to operate with fractions as well. So numerator is the top number, denominator is the bottom number. I know I've said that. I'm going to say it a lot, actually, a lot more, so that we get this down, all right? The numerator actually tells us how many parts there are. Just like in the sandwich example, right? If we looked at, let's pretend like I drew a nice sandwich right there. It can be a happy sandwich. And then we cut this in half, right? And then you got this one piece. So you got one piece. That's how many parts there were out of 2 pieces would make the full sandwich. Remember that? Or, of course, we wrote it as you could have 2 pieces out of 4 pieces. And these 2 fractions have exactly the same value, because you're getting the same amount either way. Or 2 pieces out of 4 pieces, if we cut the sandwich into 4 pieces, is the same amount. So the denominator tells us how big the pieces are. So you could say they're cut in, the 2 pieces means they're in halves or fours and quarters. Those are 2 unique values, by the way, 2 and 4. I'm not familiar with like thirds or fifths or sixths or anything beyond that, having anything that's unique, any unique wording that goes with it. But if you see 2 as a denominator, you can say that you're dealing in halves. Or if you see 4 as a denominator, you can say that you're dealing with quarters, right? So you can have 1/2 or 2 quarters. It's the same amount, okay? So the denominator tells us how big those pieces are. That's what I'm saying about the halves and quarters. Or how many parts or pieces would make up a whole if you combine them all. So if I took your 2/4 and my 1/2 or 2/4, it would give us 4 out of 4 pieces, which gives us a whole sandwich. When we start to operate with these fractions, it's crucial to understand which is which, okay? So when I say some other fraction, like 3/7, I'll write that down actually. Now 3/7 like this, you would understand that we're dealing with 3 pieces that are size sevenths. And the TH at the end of that is important. Just, don't do it to any people around you, because for me, sometimes people get more weather than news, you know what I'm saying? So bottom part, yeah, and we can say that for any fraction. Really, you can, for the most part anyways, you can say, well, like if this was a 12, that would be 12ths. And see, I got a little bit on my screen right here. So keep that in mind. The bottom number is the denominator, which tells us how many pieces make a whole or how big the pieces are. And the numerator tells us how many pieces there are. So again, 2 pieces out of 4 for you, 2 pieces out of 4 for me. When we look at those fractions, let's look over here at 1/2 and 2/4, okay? If you look at fractions that have different, they look different, but they have the same value, like we have here in 1/2 and 2/4, or 1/2 and 2/4, same thing. And these have the same value. That's called scaling fractions. And it is possible to scale them up so that the numbers are bigger, like in 2/4 compared to 1/2. But it is also possible to scale these down so that the numbers are smaller, such as 2/4 then became 1/2. So scales, when I talk about scaling, it's kind of like if you look at a map. I know, like recently I looked at a Google map and I saw something like this as the scale. And they said this was like 50 miles or something like that. Now, of course, this length on the map was only like an inch, right, that I was looking at on my screen. So it's been scaled down so that you understand that the same length is also 50 miles. It's scaled, but it's also an equivalent fraction. So whatever this is, like 1 inch, is the same as 50 miles, scaled. I hope that wasn't super confusing. So if you didn't like the map example, then perhaps you would prefer the sandwich example. You know what? I got one more in me. Let's do this. A common fraction would be like 1/2, right? Which we've seen. And if I said, hey, this is cups of flour right here, right? Let's say this is 1/2 cup of flour for 1 batch of cookies. And so it is possible to scale that. How do I want to explain this? So to scale this would say, well, it is possible if you only had 1/4 cups that you would need 2 scoops of it. So that'd be 2/4 cups. It's the same thing. But again, if you only have a 1/4 size cup, then it may be important to scale this into 2/4. Inside, I feel decent about those examples, but I like the sandwich one the most. So let's look at these examples. And all we're doing on this 4 examples is identifying the numerator and denominator. That is all. We don't have to worry about maybe changing these values or finding equivalent values like we did with the sandwich example. All right, so 1/2 right here on this one. And I'll see if I can use some technology to make this work, although sometimes it goes haywire. But I see the 1 on the top, that is the numerator, or how many parts there are. The denominator is the bottom number in that fraction, which is, in this case, 2. Boom, numerator and denominator. That's all we need to do on this one, is label the numerator and denominator so that we can get a little bit more familiarity with this vocabulary on this, okay? So the same thing with 3/4. 3 is the numerator because it's the top number. 4 is the denominator because it's the bottom number. Well, since I'm on the technology roll right here, let's see if this will work. Boom, I did it. Yep, same with 7/13. 7 is the numerator, 13 is the denominator. Or 9/21. 9 is the numerator, 21 is the denominator. And that's all we need to do in this vocabulary. Hopefully, again, this kind of solidifies what we already thought, perhaps, of numerators and denominators. But you're going to see questions like this on the assignment. It's gonna show you a fraction. You got to declare what the numerator and or denominator is for that specific problem. All right, excuse me. So what fraction of this circle is shaded blue? Well, we're going to make a fraction out of this, that's for sure. Now, just so you understand as well, I'm going to use boxes on this so we know that I just didn't draw a line randomly right there, okay? And the top number is the numerator, and the bottom number is the denominator. So in this circle, and it doesn't matter which of the two you start with, numerator or denominator, I'm going to start with the denominator on this one because I can see this circle has already been chopped up into equal parts. And just the fact that it's chopped up into equal parts indicates that we are using division, which is what the fraction line represents, okay? It is division. So I would say, okay, The denominator tells us how many parts make up a whole. So I'd say, I'm going to start right here. I'm going to go clockwise. So that's 1 piece, 2, 3, 4 pieces, 5 pieces, 6 pieces, 7 pieces, 8 pieces total. So since there's 8 pieces that make up the full circle, that is my denominator. How many parts make up the whole? Next up, we have to determine how many parts are shaded. Okay, well, perhaps I could have numbered that better, but I got 1, 2, 3, 4 on this. So there's 4 parts that are shaded. That's how many parts there are. You could put shaded right there, but that's 4 parts out of 8. Now that's fine, and that works as a fraction that you can put in the homework. But let's say, and I do worry sometimes about these theoreticals, but let's say that you looked at this circle right here, okay? And let's pretend like I drew a nice circle. And instead of seeing all 8 pieces, you just saw that there was this 1 piece shaded in, all 1 piece. And so you could have said, if you wanted to, depending on how it's asked in the homework, you could have said, well, I see 2 pieces, and 1 of them is shaded. That would be okay, as long as the homework allows it. It may, if it does allow this, then it may not say anything. If it does not want you to use this fraction right here, then it would say, don't simplify the fraction. So when we talk about simplifying fractions, that means we're going to take a fraction and scale it down into something, again, it's equivalent, it's equal, it has the same value, but it looks different. Again, scaling down means we would use small numbers. But simplified indicates that not only have we scaled it down into the small numbers, but these are the smallest numbers that we can find without using decimals or more fractions within the fraction. So these are equivalent. I would just stick with 4/8 for now. Okay. Again, we're just trying to get used to using fractions right now. So I know 4 is the numerator, 8 is the denominator. All right, so what fraction of this circle is shaded blue? Good question. So I got my fraction line right there. Let me put a couple boxes so I can enter some numbers in here. That looks okay. All right, now in the last example, I started with the denominator. You're welcome to do that if you'd like. But I'm going to show you now that it doesn't matter if you start with the numerator or denominator. I'm going to start with the numerator on this one. So for the numerator, I would just be looking for how many pieces of this circle are shaded blue. 1, there's just 1 piece right there. So that would be my numerator, 1. But the denominator tells us how many pieces put together would make up a whole circle in this case. So there's the 1 already shaded. There's some that are not shaded. 2, 3, 4, 5, 6 total pieces. So that then becomes our denominator. 1/6. In fact, this one is already simplified as 1/6. Of course, if you wrote that freehand, you'd be looking at just 1/6 without the boxes. Okay? So think about this circle right here. And I'm not going to go over it right now. But just think about this. If we change this question, which we could, and said, what fraction of the circle is shaded white on this one, you could see that 5 of the pieces are shaded white, but it's still out of 6 pieces total. Okay? I know that's not what it asked, but I think that's important to know that what it's asking for is just shaded blue pieces. Yeah, when you compare these fractions to other fractions, remember they have to be equivalent in value. So, yeah, like this one, it can't be simplified anymore. Particularly like the 1 right there tells us that it shouldn't be able to be simplified any further. So yeah, this wouldn't even be equal to like 1/3 for it. So mixed numbers now. So these we include this in the fractions section of this unit because there's fractions included in mixed numbers. Now, this is abstract, meaning we're using letters in place of numbers. And hopefully that's okay. But mixed numbers, yeah, they take on this form. So you have some kind of whole value right here. And yes, the protocol is this number is usually written a little bit bigger than the numbers in the fraction, right? And that way, the whole number here, which is the big number, is not mixed up with the numerator or denominator. So the fraction still takes these two terms, numerator and denominator, but they include a whole number. But the entire whole number and fraction together combined represent the entire value or the actual value of the mixed number. So let's see, it's a whole number and a fraction. That's true. We talked about that. In the mixed number, the numerator is b. So yeah, b is the numerator and c is the denominator. So just acknowledging this with a very commonly used fraction, right? 1 and a 1/2. And that's how this would be pronounced isn't the right word, but the word escapes me. Just how you would communicate this. That sounds better. 1 and 1/2, okay? 1 and 1/2, and indicates that it is together, by the way. So 1 here is the whole number, or the whole value. But we combine it with the 1/2, but again, 1 is the numerator, 2 is the denominator. So that would be 1 whole, and then 1 part out of 2. Okay, but the 1 indicates that, like if I was looking at a shaded figure, that there's a whole shaded figure, and then there's another shaded figure with 1 piece out of 2 that are shaded. So along those lines, we got this example. If one circle represents 1 whole, what fraction of area is shaded blue? But we do want this answer as a mixed number, all right? So I'm going to set up the mixed number right now just so we know where to put the values. That's my fraction line right there. And again, the whole value should be kind of bigger than the other values in the mixed number. So I got my numerator here, and then I got my denominator as the bottom number in the fraction. Okay? Now again, the whole number here, the big number in the mixed number, is just how many whole pieces there are, fully shaded figures. And for this one, I just see one fully shaded circle. So that would be my whole number. I'll make that a little bigger right there, 1. And yeah, like I said, we try to make this a little bit bigger because think about this, if I drew a 1 right there, then it could very easily be mixed up if there were no boxes with that denominator right there. So don't do those too small. Try to make them big enough so that we can distinguish the two. And generally speaking, they just line up center-wise with the fraction line right there, okay? So that's 1. That 1 in green is this whole circle right here, okay, because it's fully shaded. And it wouldn't matter, by the way, if there were no separated lines, cutting lines on that circle, because it's just a full shaded in circle. But then on this other circle, it's only partially shaded in. Well, how much of it is shaded in with blue? I got 1 piece that's shaded blue, so that's my numerator. How many pieces are there in that circle? 1, 2, 3, 4 pieces would make that whole figure or circle. So that would be my denominator. So this is 1 and 1/4 as a mixed number. If one circle represents 1 whole, what fraction of area is shaded blue? Well, once again, I'll set this up with some boxes so I know which value goes where, or hopefully I do. So there's our whole number, there's our numerator, there's the denominator. I just need to fill in these blanks. And sure enough, we have another whole circle right here. I circled in green right there. Maybe I should have made that thicker, but that's only 1 circle. Now keep in mind, if there were other circles out here that were fully shaded, again, we don't care how much they're cut up into because we're just counting whole figures for our whole number in the mixed number, then yeah, it's possible that you can have more than 1 on these, okay? Just keep that in mind. But for this particular example, I've only got 1 fully shaded in circle. Now in the second circle, it's not fully shaded in. I guess on that last example, I started with the numerator, so I'm going to start with the denominator on this one. And sure enough, we got 1, 2, 3, 4, 5, 6 pieces make up that whole circle. So that would be my denominator right there. Now for the numerator, well, that's just counting how many pieces are shaded. And there's this 1 piece right here, 1 piece shaded. Whoops, one piece shaded out of the 6. So this, again, this would read 1 and 1/6 as a mixed number of the shaded pieces anyways. A little bit of a different way to show fractions is those mixed numbers. Now, mixed numbers is one way to classify fractions because it would include that whole value. But we also have different ways to classify fractions depending on the values of the denominators and numerators, or numerators and denominators. So, proper fractions is where the denominator is the bigger of the two numbers. Okay? And we've seen examples like that already, such as 1/2. We've even seen 1/6. I think I did something with sevenths, wasn't it like 5/7 or something like this? Would be proper fraction because the denominator is the bigger of the two values. An improper fraction is where the numerator is bigger than the denominator. So that would be an example such as this one. Let's see. Well, 3/2 is 1. Or you could say, again, it doesn't matter. It could be like 251 over 17. Okay, we just need the numerator to be bigger than the denominator. That is an improper fraction. Okay. Now keep in mind, I do use this vocabulary quite a bit, and again, you'll use it quite a bit in 950 or 980 as well. Proper fractions and improper fractions. So when we say that, it's important for you to understand proper fractions have bigger denominators than numerators. Improper fractions have bigger numerators than denominators. But again, we'll get more experience in just classifying these as we go as well. So here's some examples. These should look familiar, by the way, because when we did these before, we were changing these to mixed numbers. But this will hopefully show the relationship, even though we haven't discussed it, between improper fractions and mixed numbers. Yes, we are looking for improper fractions here. So I'm gonna write my fraction lines, starting if I can do that decently. Yeah, we'll have a box right here to fill in for the numerator, and a box right here to fill in for the denominator. So the numerator is where we count how many pieces are shaded, and they need to be equal sized pieces. If we found that some of these were not equal sized pieces, we would need to continue cutting them until they were the same size pieces. Keep that in mind because that's an important concept when we start operating with these fractions. If they're not cut into equal pieces, then we can't just write this out correctly, okay? When we look at the denominator, remember the denominator tells us the size of the pieces, so they need to be cut up into those same sizes, all right? These ones are already cut up in the same size, which is nice. That's very generous of them. So for us, on this one, I'm going to start with the numerator. How many pieces are shaded blue? I got 1, 2, 3, 4, 5 pieces that are shaded blue. So that means that my numerator will be 5. Now, since it's an improper fraction, I should have a smaller number in the denominator, but let's see what that denominator should be, and that should be the size, again, how many pieces will make up one full circle. So that's 1, 2, 3, 4 pieces will make up full circle, so this would read as 5/4. And again, if you were to write this, I guess freehand, we'll say it'd be 5/4, something like this. And that is this same example as a improper fraction. All right, same thing on this one. If one circle represents one whole, then we need to write this scenario as an improper fraction. But again, we're looking at what fraction of the area is shaded blue. So improper fraction means we should only have one numerator and one denominator. So I'm just going to write these in. I'm not going to worry about the boxing anymore. And where I started with the numerator on that last example, on this one, I'll start with the denominator. So I'm just counting how many pieces will make up one full circle. So how many pieces is that? 1, 2, 3, 4, 5, 6. So 6 pieces make up a full circle, which indicates that 6 is our denominator. And then the numerator, again, is how many of those pieces, and these do all need to be sixths. That's important to remember. How many of those pieces are shaded blue? Well, we've counted the 6 in that first circle, and then I got the 7th one here from the second circle. That's 7 of the sixths. Sixths. There we go. But do remember, and this is important to remember, that as a mixed number, this used to be 1 and 1/6. Okay, and I just want you to think about the relationship between the mixed number and this improper fraction, because they have exactly the same value, but they're shown in different ways. And so next up, what they're going to do is they're going to want us to be able to convert improper fractions to mixed numbers, and also mixed numbers to improper fractions, because there is usefulness to the difference between these two. All right. And just so we understand the difference, improper fractions, I don't know that they have a lot of usefulness in what you would call the real world. But when we look at just pure mathematics, which is the class we're in, of course, using improper fractions generally is the way to go. Okay? It makes performing calculations or operations with fractions a lot easier. Whereas in the real world, mixed numbers are generally more used and have more applications, such as, I don't know, construction or cooking. Okay? Now, when we want to change an improper fraction to a mixed number, what we're going to do is use long division, right? Because remember, for an improper fraction, you're going to have a numerator. That's the top number here, numerator. And the bottom number is the denominator. Yes, and numerators and denominators. I don't know that I've ever seen one, but it seems like there's a good Arnold Schwarzenegger joke in that, okay? But in any case, I'll let you handle that. Yeah, this could also be written as just, straight division on this one. So that would be numerator. Oh, maybe I should have given myself more space. Here we go. Numerator divided by the denominator. And yes, I should have given myself more space, or just written it smaller, but there we go. Well, this is telling us to use long division. Okay, no problem, right? That means we're going to take that numerator. There we go. And this would be the dividend, so that should be on the inside of the long division. And then the denominator should be on the outside. Okay, so there we go. It should set up something like this. Okay? Or if we look at well, I guess we haven't seen this example yet, but I'll use one that I've shown already, 3/2, 3/2. If we were to write this as long division, the numerator goes on the inside, that's the 3 of the division, and the 2, the denominator, goes on the outside. So that's 3 divided by 2. But remember, the quotient, whatever you get on the quotient for the long division, it goes right here, right? The quotient is the whole number in the mixed number. The remainder is the numerator of the mixed number, fraction, and the denominator stays the denominator. So whatever you see as the denominator of your improper fraction, if you change it to a mixed number, it's just going to stay that same denominator, because again, we're not changing the sizes of the pieces. They're always going to be that same size piece. So here we go. We got this fraction, and I can see 35 is the numerator, 8 is the denominator, and I want to change this into a mixed number, okay? So I got my fraction line right there, and again, you'd be filling in boxes for this mixed number. There's our whole value right there. So remember, the whole value here is the quotient, the remainder is the numerator, and then the denominator on this one, remember, it's going to stay the same. So where I see the 8 as the denominator, that means I can go ahead and write it in as the denominator of the mixed number there as well. Okay, so that's a pretty good start, right? It takes care of one of the 3 values. But I'm going to use long division to actually find the quotient, or the whole number, and then the numerator, or the remainder. So our numerator there is 35. 35 divided by 8. So let's go ahead and do some division, and we should have this one down pretty good. I know 8 goes into 35 4 times, because 4 times 8 is 32. It doesn't go into it exactly. That's okay. We almost expected there to be some kind of remainder. And 35 minus 32 there is a remainder of 3. And yeah, that takes up all of our 1s and 10s, by the way. So where my quotient there is 4, that will be the whole value, right? That's from the 4 there is the quotient. And my remainder of 3, that will be my numerator, 3. And again, we already have the denominator of 8. So 35/8 has the same exact value as 4 3/8. But just know this is coming up. We're going to be eventually changing these mixed numbers also into improper fractions. Let's change this improper fraction to a mixed number. Remember, this is an improper fraction because the numerator is bigger than the denominator. Now, just think about this as well, and I probably should have mentioned this before, but since the numerator is bigger than the denominator, that means that we could split this up into this many pieces to make whole pieces, right? But again, we'll stay with our technique on this one. We want to change this into a mixed number. So I'm going to have that fraction line there, knowing that I'm going to have a whole value right here, but I'm not going to use boxes on this one because eventually you're not going to see those boxes, okay? But I have my numerator there at 37, and I am going to divide this by 6, but we're using long division, okay? So 37 divided by 6, that's how this reads, even though it shows the 6 on the left. And I know that 6 will go into 37 6 times. 6 times 6 is 36. So when I subtract that out, I get my remainder of 7 minus 6 is 1. 3's 0 out. And so my quotient there is 6. So I got the big 6 right there. My numerator is the remainder, which is 1. And while I'm doing this late in this problem, you see the denominator of 6 right there? It's going to stay the denominator in the mixed number as well. So 37/6 is the same as 6 1/6. All right, in changing mixed numbers to improper fractions, we use what I call cycle method, okay? Now remember, just like with changing improper fractions to mixed numbers, the denominator won't change, okay? So whatever you see as the denominator is in your mixed number, it will stay the denominator in the new improper fraction, all right? But all you would need then is to find the numerator. Well, we have this simple algorithm to do that. And this is where the cycle comes in. You're going to take that whole value, the a right there, whatever number that is, and multiply it by c. That's why there's a multiplication right here. And then whatever that product is between a and c, you're going to take and then add that to the existing numerator, which is shown as the b value right there. So that's why it shows down here. You got to do the multiplication first, a times c, whatever that product is, then you add the b value. So from this example that we've seen already, right, we remember that this example was 5/4 or 1 1/4, right? So remember, the 5/4 indicates that you have enough. The 5/4 indicates that you have enough to make one full piece, right? That's why you'd have 1 and then the extra fourth. That's all that would be left over, right? So that hopefully kind of, at least on the surface, explains why we're using long division to change our improper fractions to mixed numbers. Now, the other way around this is to say, well, like we have the one full piece, right? That's the one in the whole number. And then we got 1 out of 4 pieces that are shaded blue on the second circle right there. Now, the difference here is that now you're going to say, well, how many of these fourths would this full piece be? I mean, it's already cut up for us, so we can see it's 4. And that's why we multiply this whole number by the denominator here. The denominator tells us if we were to take this whole piece and split it up into those size pieces, you'd have 4 of those, or however many is in the denominator. And again, it wouldn't matter if you had another piece over here, that'd be 2. So that's 2 full pieces that are now split up into fourths. So that'd be 2 times 4, which is 8, right? That'd give you 4 here, 4 there, that's 8. And then the extra 1 would have made 9. But just for this example, right, you got the 4 that comes from 1 times 4, and then the cycle indicates that you add the 1. That's the one piece that's floating in this second circle, which would make 5 out of 4 pieces that are shaded blue. So I hope that example, just because we've seen it already, kind of helps you make that connection between not only how to convert a improper fraction to a mixed number, but also to see the reasoning behind the cycle method here in changing a mixed number into an improper fraction. All right, so here we go. We got to change this 10 and 5/9 into an improper fraction. No problem, because we know we can just use cycle method. Now, the other thing I know from working with mixed numbers and improper fractions, at least when they're equal, that the denominator should stay the same, right? So where I have a 9 denominator from the mixed number, I should keep 9 as my denominator for the improper fraction. Now I can apply cycle method. So again, that's you can take the whole value, the 10 there, and multiply it by 9, right? So that's 10 times 9. We should know that's 90. You can stack that if you need to. That's okay, and you shouldn't feel ashamed to stack. Now, again, I'm just going to emphasize what the 90 represents before I do the addition, okay, from the cycle method. So these 10 pieces, I cut them all up into 9 pieces each. So that'd be 10 times 9, right? 10 groups of this 9 because each is 9 pieces. That's why we get this 90 right here. But then you got the 5 out of the other circle, if you want to use circles. And that's why we'd have to add these 5 right here, okay? So I got to take those 90, and then I got 5 more of those pieces, just like we saw in the circle example, which gives us a total of 95 total pieces that, well, if they were shaded, like the circles were, that would be shaded. That is our numerator, 95. So 10 and 5/9 now becomes 95/9. That's our equivalent improper fraction. So I do want to reemphasize this as well. Now, while dealing with mixed numbers with normal everyday applications, it's true that they're more convenient, generally speaking. But when we're dealing with just the pure mathematics, this is why this skill becomes extraordinarily important, is changing these into improper fractions, because working with improper fractions with pure mathematics is generally a lot easier than working with the mixed numbers. So let's change this 20 and 1/2 into an improper fraction using, I'm going to use cycle method again, okay? But the first thing I notice, again, since we are changing this mixed number into a improper fraction, is that the denominator should stay the same. So where I have a 2 denominator with the mixed number, it's going to stay 2 denominator for the improper fraction. All I need to do is find the numerator. So I apply cycle method, and yeah, the first operation is multiplication. So I take the whole number, 20, and multiply it by 2. And I'm stacking this just to show you that, I mean, there are some scenarios where you may find it useful to stack these for multiplication. There is another method, but we have to wait till 950 to show that method. So 0 times 2 in the ones place value, that's a 0. And then 2 times 2 is 4. So that's 40 from the multiplication. Now I take that product 40 and I add it to the numerator that exists already, that's 1. So I take 40 and add 1, and that will be my new numerator, 41. So 20 and 1/2 converts into 40 halves, or 40 over 2. And yes, it is possible, if you were to use long division with 41 over 2, you would get the same mixed number, 20 and 1/2. I like this example because we're dealing with some unusual values, right? We saw like 10 and 20 as the whole values. But it's nice to see some unusual answers or whole numbers like this, okay? And even 7 as denominator, that's okay. So, applying my cycle method to change this into an improper fraction. Actually, before that, again, I'm going to go back and say, well, I can identify the the denominator, which in this case is 7. So my new denominator, not really new, but it will stay 7. The denominator will stay 7, okay? So that takes care of one of the two values that is part of our improper fraction, but I'm going to use apply cycle method to change this or to find my numerator. So that's 13 times 7 right there, and yeah, I can't do 13 times 7 in my head. Maybe you can. If you can, that's great, but I'm going to show the work for it. So 3 times 7 is 21. I'm going to carry the 2 there. 7 times 1 is 7, but plus the 2 makes that 91. See that? Now that's the product. I still need to perform the addition part of this, which I'm just going to add the numerator. So 91, that's our product, plus the 6 numerator, and this result, this sum, will give us the new numerator. So 1 plus 6 is 7. I'll drop the 9 to make that 97. This is our numerator of the improper fraction. So 91/7 is the same as 13 6/7, just as an improper fraction, that's all. And again, it is possible to go both ways, so some people prefer to see both arrows, but either way. I got hooked on my 91 on that one. I apologize. It is 97. Thank you. Yeah, 97/7 is the same as 13 6/7. So graphing fractions and mixed numbers. And we could see fractions as improper fractions or proper fractions. Doesn't really matter. But remember that the denominator is telling us how much each unit is split up into, okay? So, like if you see a denominator of 2, then each unit should split up into 2 parts. Or if you saw 3, it should split up into 3 parts, and so forth. The numerator tells us how many parts, says how many parts into the unit. So how many, well, I think that sounds good. So you're just counting. The numerator tells you how many how many of those parts to count. That may not make a lot of sense right now, but I hope the examples we go over will. Now, I'm doing these all freehand, but do understand that on the homework, these are the graphs are already made for you. And the other thing about those graphs, I'm only going to do it on this one because I'm doing it by hand. I don't want to get too confusing, but right in the middle is 0. And just understand that these number lines are going to get bigger the farther to the right you go. So the farther to the left you go, the numbers are technically smaller or lesser in value. And once you pass 0 going to the left, then we get into negative value. So it is possible you may see like a -1 over here and then like a 1 over here, okay? Now, you'll have to forgive me for not splitting these up into equal parts. I am actually doing my best. I feel like there's a good happy tree joke in there, but again, I'll let you finish that up. So this one is 1/6, right? So I would focus first on the denominator here so I know how to split up each of these units. And by units, I'm talking about whole values like 1 or -1 or 2 or 3, okay? So I need 6 different parts on this. Now be careful because a lot of students are like 1, 2, 3, 4, 5, 6. But what you just did is you split that up into 7 parts, right? If you counted that, it's 1, 2, 3, 4, 5, 6, 7. So we cannot do that. Okay, don't do that. Because this mark right here for the 1, that's already one of the marks of the 6 that we need. So that's 1, 2, 3, 4, 5, 6. And again, we're still pretending like I split those up into equal parts. And yeah, we can do the same thing on the left here. So 1, 2, 3, 4, 5, and then the -1 there is the 6th part of that. Now we just need to identify 1/6 on this. Let's see if I can fit this in here. So on this one, you got 0, that'd be kind of like 0/6, but this first mark would be 1/6, then 2/6, and that can be scaled down, by the way, but I'm not worried about that right now because we're just focusing on 6, and hopefully this will help you to understand how to split these up, at least if you're doing it by hand, even though on the homework you won't have to. 2/6, 3/6, then 4/6, 5/6, and that should help us to understand that 1 is the same as 6/6, right? Anything divided by itself is 1. In this problem, it wants us to identify 1/6 on the graph. And how are we going to do that, 1/6? Well, it's 1 out of the 6 parts. That's this mark right here. On the homework, you're just gonna put a dot right there. That's all. And that's it. That's all we got to do to graph 1/6. So you're not going to be required to label these. In fact, on the homework, none of those labels are going to show up. But if you got to show that on scratch paper so that you know what you're dealing with, then if that helps, then do it. Okay. All right. So that last problem, that was a proper fraction. On this one, we're looking at a mixed number. Okay. So I'm going to start with 0 here. Again, I'm not worried about negatives because I'm doing this freehand. And I need to get up at least 2, right? So I'd say, there's 1, and then 2, and I'll even show all the way up to 3. Particularly because this mixed number is beyond 2, right? It's 2 and then another fourth. So I'm going to split this up into fourths, each of these into fourths, just so we know that it's in fourths. That'd be 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I kind of jacked up the spacing on that last part, but that's okay because I'm doing it by hand, hopefully. So here's what I do when so first of all, of course, when I'm doing this by hand, I show the graph with all my whole values labeled, and then I just split up all the other parts up into their, what should be equal parts, but I'm doing it by hand, so it's not so great, but it still works. Now to find the number that it gives us for mixed numbers, I would start first with the whole value, 2, right? So, there's my 2 on the graph. Now, if I've done this right, each of the units has been split up into fourths. 1, 2, 3, 4. So that's 4 parts between the 2 and 3, so it is in fourths. I only need one of those fourths, which would be this mark right here. So this clearly takes us to 2. See if I can fit this in here. The 2 that we found right there, right? Underlined in green. And this is 1 out of 4 parts right there. So that's where I need to make my mark. I'll put it in orange. That's okay. That's pretty good. So again, this is what you can do on the homework. You're just going to put a mark there, a dot, and that's graphing, in this case, 2 1/4. All right. Well, what about 10/3? 10/3, that's a improper fraction. No problem. We can still do that. But again, for me, I'm going to start with 0 here. Now, I'm going to start with 0, and I'm going to go, because 10/3 really isn't that big, and we shouldn't be expecting anything too big right now when we're looking at graphs. So I'm going to say, well, every third mark is 1, right? So that's 0, 1/3, 2/3, 3/3 is 1, 4/3, 5/3, 6/3, that'd be 2, 7/3, 8/3, 9/3, that's 3, 10/3, 11/3, and 12/3 would be 4. So I did go all the way up to 4, even though I did pass 10/3 on this, okay? So just by counting these in thirds, which we can do, and I'll show these labeled, right, because that's how I did it when I counted these through. I had 1/3 here, 2/3 here, 3/3, that's the 1, 4/3 there, then 5/3, I mean that gives us halfway there, but 2 would be 6/3, then 7/3, 8/3, we're trying to get to 10/3, right? And then 9/3 is 3, and then behold, 10/3. So that's where my 10/3 is, so I can put a point right there if I want to. Now, along the lines of these two examples that we just barely did, is the idea of changing these into mixed numbers. Like if you have an improper fraction like this example, If you would prefer to graph this as a mixed number, feel free to do that, okay? So you just take your 10 numerator and divide it by your 3 denominator. 3 goes into 10 3 times. 3 times 3 is 9. Subtract, you got a remainder of 1. So that makes 10 thirds the same as 3 and 1 third. And we're going to keep that denominator there as 3. We had 3 quotient, and then the remainder 1 here as our numerator. And what is this? That's 3, and then an extra third right there. Especially since I had these already split up into thirds. 1, 2, 3 parts to make the full unit. So on this example that we already did, which started as a mixed number, if you would prefer to do this as a improper fraction, you could. So just as a little practice, we would look at 2 1/4 and change it to an improper fraction. We're using cycle method here. So that's 2 times 4 there. 2 times 4 is 8. And then we'd need to add the 1 numerator right there, plus 1. Makes our new numerator 9. So 2 1/4 then becomes 9, but keep the denominator as 4/4. 9/4. And how's that 9/4? Well, this is already split up into 4, so there's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, just where we marked it there in orange. Okay? So I don't really care which method you use. If you prefer to see mixed numbers as improper fractions, feel free to do it. If you prefer to see improper fractions as mixed numbers, feel free to do that. It doesn't matter as long as you nail the spot where this point is supposed to go on your graphs. You'll get the right answer either way.